So with a couple of those first examples, we were able to find the limits, but we needed some time to do it. We had to make a graph, we had to use a graphic calculator to pull up a table. Is there a quicker way to find limits? And in fact, there is. So if we're looking to define limits analytically, we're looking to figure out these limits in a quick and easy manner in order to get things squared away. And if we're talking about functions which don't really have anything big going on, no breaks, no jumps, no gaps, then the limits can actually be found quite quickly. Let's go back to a nice favorite of y equals x squared. So let's say that we were asked for the limit as x approaches 4 of x squared. Okay, and well, we're going to do this the old-fashioned way, real quick, because we can do it really quickly. The graph of x squared, okay? Well, what's that graph look like? Exactly, it's a parabola. All right, so if we have the graph of y equals x squared, change colors right here, then we're looking at that graph right here. All right, there's y equals x squared. And if we want the limit as x approaches 4, let me get 4 onto the x-axis. We'll get it right there. Okay, and well, now we start looking at the limit as x approaches 4, so we're interested in what's going on with our function as we approach both from the left and the right. That's the key thing, is we want the fingers to match up on the graph as we approach from both sides. Okay, and if we do that, we see that we have this happening from the left side, and we have that happening from the right side, so it does look like they are going to in fact meet up. Okay, and the question is, not really do they meet up, because they will, but what's the value, the y value of the function, when we actually see these two meet up on our curve, all right? And where are we heading over? Okay, well, what's the y value of the function when x is equal to 4? Y is equal to x squared, x is 4, 4 squared is 16. There's our limit. Okay, the limit as x approaches 4 of x squared is going to be 16, because 4 squared is equal to 16. So in other words, all we really need to do to find a limit, if it works out, is to just plug in the value of x in which we are heading. Okay, so look at example 7 and on the paper right there. We see the limit as x approaches 1 of x squared plus 5x, this is example 7, right here. Limit as x approaches 1 of x squared plus 5x. For example 7, we see the limit as x approaches 1 of x squared plus 5x minus 4. And we can just plug in 1. That'll work out. All right, if we plug 1 into this function, we have 1 squared plus 5 times 1. Oops, there should be an x right here, I believe. It should be x to the 4th. There we go. Minus 1 to the 4th. 1 plus 5 minus 1 brings us back to 5, doesn't it? There's our limit. Okay? Nice and easy. If you've got a limit, plug in the value. Take a second and do number 8, please. Example number 8.